What's going on? Welcome back. In today's video, we're going to be talking about threat hunting with Sysmon. Sysmon stands for System Monitor, and it is a Microsoft internal tool. You can download that and install it on your computer. Now, Sysmon is used to, as you can see here, collect, analyze, and send logs to either a SIEM device or to workstation log. If you don't know what is SIEM device, it is Security Information Event Management, which are log aggregators collecting logs from various endpoints on the network in order for you as a blue teamer to analyze these logs and detect incidents. So if you don't know what is SIEM, I think you'll have to do a fresh up on your blue team skills. So now the logs that are sent by Sysmon, once you install Sysmon on your endpoints, will be sent to SIEM device or workstation logs. Workstation logs could be Linux, syslogs, or could be Windows. So if you are using Linux, you'll be able to analyze the logs with syslog. If you're using Windows, you'll be able to analyze the logs with Windows Event Viewer or with the equivalent command line tools such as get win event in PowerShell or win event utility in command line. Now that we understand what is the purpose of Sysmon, let's find out what Sysmon will detect, what Sysmon will analyze, and what are the type of logs that we can configure with Sysmon. So first thing first, Sysmon operates on a configuration file. The configuration file is a file that you configure with rules. The rules are used to detect incidents. So you can find examples of Sysmon config online. In this scenario, we're going to be using the one created by TryHackMe, or not TryHackMe actually, created by Swift on Security company, and we will analyze the rules on that file. So the sysconfig file or Sysmon config file is used to create the incidents, where you will list your rules, as I said earlier. Now, in the example that we will be examining in this scenario, the config file is configured with rules to detect the following events. 9 types of events. The first type is process creation. So Sysmon will alert us or alert the Windows event log or the SIEM device or send log if a process is created. And the event ID for that is 1. So why we use process creation rules? Because most malwares, when they are dropped in your workstation, they will create processes. So you want to be alerted about the processes being created. Of course, we can include specific processes. Network connections. Now, the network connections, why do we also send events for network connections? Because we know that malwares communicate with command and control centers or foreign IP addresses. So we want to be alerted when that happens. DLLs loaded. Most malwares also use DLLs, or when a DLL injection attack happens, a DLL is loaded or replaced with another DLL. So we want to be alerted about that. And these are the event IDs that we will use when we examine that. Process hollowing. Process hollowing is where a process, all right, is accessing or inserting another thread in another process to hide itself. So this is typically the case with many malwares, and you want to be alerted when that happens. And the event ID for that is 8. The same with process access. A process such as task scheduler accessing another process such as Notepad. We want to be alerted about that behavior as well. Event ID is 10. And file created. So usually malwares or Trojan downloaders or droppers, they download files over the internet. So they used to create workstation, or they used to create files on the workstation. That's why we need to be alerted when a file is created. Registry keys. They manipulate the registry keys, creating registry keys or values under, let's say, current version or run in order to execute startup scripts. These are the event IDs. Alternate data streams. Now, alternate data streams is used with Windows heavily, but Malwares use alternative data streams to bypass detections. So we can detect these kind of techniques if we look for any files created in an alternate data stream. The last one is DNS events. We're also to be alerted when a DNS query is made to the outside network. Now, we're going to switch to the practical scenario. We're going to be taking a look at a sample configuration file from TryHackMe for Sysmon, and we will be answering the questions for the challenge. The challenge is about a scenario where a machine is infected with malicious file from a USB device, and the file was downloading another file and using evasion techniques. So we will be discovering that with Sysmon and analyze the events. So make sure you are connected, and of course turn on the machine. Let me switch now to the virtual machine. So let's see here. I think we need to create a new connection. The IP address, and we will need also the username and password. Let me cancel that. Select auto detect connect. All right, while we get the connection to work, let me show you how to download the Sysmon. So basically, I hate this. Okay. No, this is the password. Okay, you can download Sysmon from here. Once you download Sysmon, you can execute that and it will work as a service, as you can see here. Now, the configuration file of Sysmon, you can configure Sysmon technically by, let me choose config. So basically here, after we download Sysmon, you can execute the following command, sysmon64-i and the configuration file. Now basically the configuration file is a file that you create, okay? You can put the file whenever you want, wherever you want in your workstation. And most importantly is to specify the path when you execute or when you include the configuration file with Sysmon. Let's take a look at an example configuration file. You can go to GitHub and download this example configuration file, IonStorm. The example configuration file here will be used throughout the scenario. And as you can see, these are the rules created. It's a big file. And this file is used to detect ransomwares, malwares, Trojans. Most security incidents are covered in this file. Of course, you are free to add your own rules to cover more incidents. Okay, so now let's take an example from these rules. So for example, as you can see, the first rule. So rule group, the name is process create, include the group. Let's take the file to our to my machine. Let's download that. keep. So we open the, let me check. Yeah, let's open the configuration file with Sublime. All right, so let's check some example rule sets. So as you can see, this is the first one. This rule alerts when a process is created. And below that, we can see onMatch equal to include, which means that we want to include all of these rules, or we want to include all of these matches when the process is created. For example, alert unknown process execution condition contains unknown process. So if a process is titled as unknown process, it will trigger an alert. And also we see here MITRE technique reversed condition image. Also, if there is a process created under this name, it will give you an alert. The same goes with the rest of the processes. So that the first one here, the first rule set, triggers an alert or triggers an event to be logged when a process is created and is included in one of these images or parent image. Let's examine another rule set. So we have another one here, process create exclude group. So as you can see, this is another rule that excludes specific processes in a way to cut down on the noise or on the false positives. So whatever you put here, all right, will be excluded from the event logging. So these processes will be flagged as not malicious by your Sysmon. Why? Because you instructed Sysmon to exclude these processes by using onMatch equal exclude. Let's see here, what do we have? So another rule group here is the file create. So we want to be alerted when a file is created. The rule will trigger an event to be logged whenever one of these files, or if the file actually is stored in one of these paths, start menu, startup, drivers, prefetch, it will trigger an alert. Let's see here, what do we have as well? So registry events, rule group to trigger an alert when a registry key is created, accessed, or modified. And the onMatch is include, which means we want the log to be created when one of these conditions is matched. For example, the name here contains current version run. So whenever the registry key that ends with or contains current version run is modified, you will be alerted. Why? Because many malwares use this registry key to store values to be run after the system starts. And here, Windows System Scripts, you will be also alerted when something is stored in this registry path. Why? Because many times malwares use persistence scripts and register the values under this path of the registry in order to execute scripts at a startup or after a specific criteria is met. So you want to be alerted whenever this registry path is modified or whenever a value is stored there. All right, so that is an example of the Sysmon config file. It is very vital for Sysmon to work correctly from you to include these kind of files, the configuration file. You can download this file for free. You can find many example Sysmon configuration files, and you can create your own, of course, and add on existing ones. Of course, you have to understand these rules, all right, how they work in order to create your own rules based on your threat intelligence or based on your threat hunting experience. For example, you might come across a malware that when executed, creates a process that matches specific name. So you want to add the process name here, all right, as an image name in your existing configuration file so that Sysmon will send you a log event when this process is executed or when similar processes are executed. All right, so that's the configuration file. And now let's head back to the virtual machine. We will examine example logs created by Sysmon. All right, we will be extracting details about the incident that happened in the scenario from TryHackMe, and we will answer the questions. So right now I deployed the machine. It will take about 47 seconds. So we will answer the questions pertaining to the scenario here. The scenario here is we have we have five investigation files. The files are taken from event log. So suppose put yourself in the shoes of the investigator. You will be given the event log files, and you will be required to analyze the files to extract artifacts related to how the attack happened, artifacts about the attacker, and other artifacts about the payload used in the attack. The first example is saying, investigation. In this investigation, your team has received reports that a malicious file was dropped onto a host by a malicious USB. They have pulled the logs suspected and have tasked you with running the investigation for it. Let's take the details about the virtual machine first and log in. So, not clicking, problem. All right, let's create a new one. Okay, let's make that bigger. So, okay, so let's click on scenarios. So we will be answering the questions pertaining to the investigations folder, but if you want, you can go over the practice. These are the logs collected by your team. Now, you might be asking me how this relates to sysmonitor. So you have this machine here that has sysmonitor installed, and the configuration file that has been used is the configuration file I showed you a while ago. Now, you can find all of the Sysmon events. I'm going to show you where sysmonitor log the events. So if you click on event viewer from here, oh my god, this board, for God's sake, I don't know why it is very creepy. Okay, so basically sysmonitor stores the logs in applications and services. If you expand this view here, just wait for that to pop up. Okay, so under applications and services logs, you will find here Microsoft. Expand the Microsoft, go to Windows. Under Windows, if we scroll down until we see Sysmon, So here you go, Sysmonitor. Expand that, click on operational, and here you will see all of the Sysmonitor logs, all of the logs that Sysmonitor have collected and sent to your event viewer. Normally, if you're working in an enterprise or in a SOC team, you will see these logs in a device called Security and Information Event Management device, such as Splunk or Alien Vault. But for this scenario, we are examining the logs from our workstation. Now, if you go back, these logs are collected from this view here. But how they are separated, as you can see here, they are separated by the event type. So if you go back to the board here, as you can see here, we spoke about the type of events Sysmonitor detects, right? And we also expanded here the kind of the numbers of the event IDs, right? So we take the event ID, for example, we want to filter for the process creation logs. So we take the event ID 1, filter current log 11, okay. And now we can click on Save Filtered Log File As. That's how these logs are collected. So your team has sifted through all of these events. They have created these events for you in order for you to analyze. Okay, that's how these log files are created or gathered. So normally, if you are running Sysmon on your device and you found this huge number of, let me clear the filter, huge number of events created by Sysmon, all you have to do is to just understand what are the event IDs correlated or that are corresponding to the type of process. For example, here the process is now a connection, didn't load it. So take the event ID and filter based on what you want. Okay, let's close that and expand here. These are practice scenarios. Okay, if we, for example, let's take one, detecting remote threats. Remote threats are threats created by a process in another process, and typically it is a malicious behavior. So basically you can see the event. Let me take this right up. So let's see, detecting remote threats, and these are all of the events that correspond to the scenario. But we are assuming that you are sifting through a huge number of events, right? So we will not be using the graphical GUI here. We will be using the command line tools, specifically the PowerShell. Now that you have given the log files, your task as a SOC team to analyze these log files. So you will open PowerShell as administrator. You will navigate to the, let's make the font bigger, properties, font. So users cd THM, analyst cd desktop, go to scenarios, practice, clear. So we have these logs. Okay, so for example, hunting Metasploit. So in this log file, your team believes that the collected logs generated by Sysmonitor are hinting about Metasploit activity. So how do you go about detecting Metasploit activity from an event log file? So you would need the power of get win event. So get win event, and then we define the path, which is hunting Metasploit, hunting Metasploit here. Okay, now we type xpath or filter. If you don't know what is filter xpath, you can go to the last video I have created where I explained how to use XML queries to filter through your events. Okay, now let me open my file. So here are the commands. So basically, if I want to detect Metasploit activity, I want to look for ports 44s, and I want to look for event ID equal 3. So why do I do that? Because Metasploit commonly uses the port 44s, right? In your R host, R ports configuration, if you're doing if you're creating a payload, the port 44s comes predefined in the R port configuration of Metasploit. That's why here we are filtering for the port 44s. And event ID equal 3 because 3 corresponds to network connection. So you want to configure a network, an event where there is a network connection and where the port is 44s, which means that could be possibly Metasploit. Possibly, I mean, not necessarily. So let me copy the comment from here, take this, paste, enter. So as you can see, we have one event. Now, if we want to get more information about that event, we type FL to display that in a list format. Okay, so these are the information of the event. As you can see here, we can see the process that initiated the connection. It is shell.exe and exists in downloads, which means that the user possibly has downloaded the file from an email attachment, and the file has been stored in the downloads. After they executed the file, which is shell.exe, it has initiated a connection to this IP address and this port. 44s. Possibly there is an omitted 4 here, but it is 44s. So this is the event that relates to Metasploit. Now, if we go up, let's examine the Mimikatz one. How do you know that there is a Mimikatz activity on my network or on my host? So let's get back to the list of commands and let's take, let's see here, which one? Okay, so let's take this one. I'm going to explain that while I execute the command. So I'll copy that, get back. So basically, I'm going to remove these characters. And here we define Mimikatz dash. Oh, wait. So basically here we have Mimikatz dash filter xpath paste. Now, to detect, or not to detect actually, it has already been detected by Sysmonitor. To filter for Mimikatz events, you have to use 2 criteria. The first one, the event ID equal 10. Why 10? If you get back here, 10 corresponds to process access. And Mimikatz, when Mimikatz is used against a target machine, it accesses another process. The process name is LSAS, which is the Local Security Authority process, responsible for creating and authenticating users on your machine. Mimikatz, when you issue dump credentials with Mimikatz, Mimikatz will access this process, all right, and dump the credentials. So we want to filter for the events where the event ID equal 10 corresponding to process access, and the process that has been accessed must be LSAS. That's how we know that actually there was Mimikatz running against the machine. So if we hit enter, we see there is one. The message is process access. If you want to list more information about that, we type FL, and we see here the full details. So the source image, C users downloads Mimikatz. So again, the attacker has dropped the Mimikatz in the downloads folder, and they executed Mimikatz from there. And target image, the target image is the process that has been accessed by the source image here, which is Mimikatz. And here you can see the call trace. So that's how we know. Now you can do the same with other practice files. I'm going to hit now directly to save time to the challenge. So you can find the challenge files in scenarios, investigations, and here are the challenge files. You will get the idea. You will understand everything while we go through the challenge. So back to challenge. The first scenario here. We read about this, right? There was a malicious file dropped by a USB. The investigation questions are, we have 3 questions. The first one, what is the full registry key of the USB device calling service host in investigation 1? So here we want to extract the registry key that contains information about the malicious USB, right? So for that reason, we will use the event ID 13, 12, or 14 to find more information about what registry key that has been modified. So the same command here stands, but let's go back to and cd to investigations. So here, let's work on the command. Or let me copy the command directly from here. So let's take the first one. All right, so we define the path to the event file, and here we filter for event ID 13 because we're looking for modifications on registry keys. Here I put maximum events 2. I want to display maximum only 2 events and sort them by the oldest. So let's see here. So the rule name set value. This is the rule in where you guess in sysmonitor that triggered the event. And we see the image, as you can see, Windows portable device, devices, and here goes the device ID of the USB. As you can see, it is USB cruiser. So this is the registry key containing information about the USB. So we get back to here, and you answer with this in the question. Now, what is the device name when being called by raw access read in investigation 1? So we really required to find out the device name, right? When being called by raw access read. Now, what is raw access read? Technically, if you take this, it's an event, by the way. Raw access read detected. Click on that. Event. So it is an event, has the ID of 9, and you can see more details about this. The raw access read event detects when a process conducts reading operations from the drive. So basically, the malicious process is inquiring or querying the USB drive where it came from to take more commands or instructions about the malicious process. So if you get back here and we scroll down, instead of event 13, we type 9. So here we see raw access read detected, and it's the image volume 3 in both cases. So the answer to the question let me also close yeah. Let's go back to TryHackMe. Click on that. So what is the device name when being called by raw access read investigation 1? It is this one, as we found out. What is the first process executes investigation 1. So here we try to find out what was the process that was executed when we plugged the USB drive. So I found out just by changing the event ID to 1, which corresponds to process create alert in sysmonitor, of course, 1. And here you will see the process name is, actually you have got 2. Let me check. No, only 1 actually. So as you can see, the process name is run DLL32. Now we move on to investigation 2. Let's read the scenario. Another suspicious file has appeared in your logs and has managed to execute code masking itself as an HTML file. Evading your antivirus detections, open the logs and investigate the suspicious file. So there is another suspicious file or suspicious process that has masked itself as HTML file and is executed itself actually as HTML file. So it has used something called alternate data streams. So let's filter for alternate data streams to find out about this. So if we go back to here and we see ID is 15, let's check on ID 15. Change the file to investigations 2. So there is nothing that matched the event ID 15. Okay. Let's check on the processes created. So the first process that has been created from this investigation file, let's check out here. So this is the process, right? The original process. The original file name is here. Now, if we go back, if you go down, you see the process here, which is mshta, has executed a file called update.hta, right? And if you go down, you see there is something called the parent image. The parent image refers to a completely same file name, update but with different extension, which means that the original file name was update.hta, but the malware has executed the file as update.html by looking at the parent image. So if you go back, see the answer here. What is the full path of the payload in investigation 2? The full path will be this one. This is where the payload lives on the workstation in this path. Now, second question is, what is the full path of the file, the payload mask itself as an investigation? So this is the original payload, but the file that the payload has used to hide its identity was here in the parent image section. Now, what signed binary executed the payload in the investigation 2? This is the binary that executed the payload. Now, what is the IP address of the adversary in investigation 2? So now I have to find out the IP address that is used to, or that's used by the malware to make the connection. So basically we filter for network connections, which is the event ID. Let me remember. So let's go back. Remind myself of that. 3. So filter for 3. So here we see only one event, and this is the source IP, which is the machine IP address that is making the connection. And this is the process name, which corresponds to the same process we found previously when filtering for the payloads. And it's making the connection to the IP address here and on this port. So this answers this question and this one. Now we go to the investigation, or the third part of the investigation, which is your team has informed you that the adversary has managed to set up persistence on your endpoints as they continue to move throughout your network. Find how the adversary managed to gain persistence using the logs provided. So most probably when there is persistence on a machine, we want to look for event IDs or alerts that correspond to registry modification. So in the file, we first define the path, which is 3.1. And here we define, or we filter for events ID 12. See if we have got something. So I have got something here. Let's see. So here we're required to find the questions. What are the questions here? So the first question in investigation, part 3, what is the IP of the suspected adversary in investigation 3? So here, let's skip the registry. We're not required to find that. Let's find about the IP addresses. So we filter for 3, I guess. Remind myself of that. 3 for network connections. Filter. So we see 3 here. 3 connection attempts. Source IP, my workstation, and this destination IP. Let's compare that with the second event. And we see the same IP address used in both cases as the destination IP, which means the destination IP was this one, and the destination port was 80. This answers the question here. What is the host name of the affected endpoint? So to find out about the affected endpoint, we look at the source IP address, and down and above that, we look at the image, which is the host of the endpoint. What is the host name of the C2 server connecting to the endpoint in investigation 3.1? The host name is pretty obvious, Empire C2. Now, where in the registry was the payload stored in investigation 3.1? So the malware, if we go back, the malware has created a payload to execute itself every time the system starts, and has created another registry keys under registry, other registry values actually in the registry keys to facilitate this process. So you have to look in the registry or to look for registry modifications. So we choose event ID equal 12. Let's make them 3 here. So we see create key. The question is, where in the registry was the payload stored? Settings, so not here. Software Windows current version, image file execution options, not here. So we're looking for payload pattern actually. Let me choose event ID 13. All right, here we got something. So this seems to be payload encoded, right? And we see here it is under HKLM software Microsoft Network Debug. Here where the payload has been stored. This marks the answer for this question. What PowerShell launch code was used to launch the payload in investigation? So the malware uses PowerShell to execute its commands. So basically, as you can see here, you see the command, right? C Windows PowerShell -exe-c, and here you see the command. So this marks the answer for the question here. So this was the launch code executed by the malware, which is PowerShell code. All right, what is the IP address of the adversary investigation 3.2? So we move to the part 2 of the third investigation. It's the same, right? Yeah, the same. So let's then go back to the questions. What is the IP address in the investigation 3.2? So here we have to change the file to B2 and look for network connections. So you would change 13 to 3, enter. We see here all of the network connections, and we see repeated pattern of the destination IP address. So the IP address, as you can see, is the same throughout the network connections, which means this was the IP address of the attacker. What is the full path of the payload located in what is the full path of the payload location in investigation 3.2? So we will have to find out the payload location. So we look for processes created, because malwares use process, right, to create payloads. So we look for process created by using ID equal 1. Go up. As you can see, this is the first process that has been created, and it is actually CMD to create the payload. So the payload is echoing some encoded stuff to C users appdata blah.txt, which is the location of the payload. What was the full command used to create the scheduled task in task 3.2? So you want to see the full command that was used by the malware to create a scheduled task in order to execute the malware frequently. So we look for a process that is using a scheduled task or task scheduler, which is here. As you can see, this process is using task scheduler. And the question is, what was the full command? So you copy that and you answer with it, which is the command here is creating a scheduled task to execute the payload in this location. All right, so what process was accessed by scheduled tasks that would be considered suspicious behavior in investigation 3.2? So scheduled task seemingly is accessing another process to perform its objective or to perform the objective of the payload. So you have to look for the events that correspond to process access or process hollowing. So we use the event ID 10. And we see here the pattern of process access. As you can see, source process ID and target process image or ID. But they are encoded, so we have to look them at in the file, event file. So open investigation 3.2. And you filter for, after it opens. So we filter for event ID 10, details. So we see scheduled tasks is accessing the process which is LSAS, which indicates the presence of Mimikatz activity, right? So the answer is process LSAS. What is the IP of the adversary in investigation 4? Move on to investigation 4. Let's read about investigation 4 up there. Mom, look, I built a botnet. As the adversary has gained a solid foothold onto your network, it has been brought to your attention that they may have been able to set up SE2 communications on some of the endpoints. Collect the logs and continue the investigation. So there is a botnet on my network. I want to find out who are where is the original command and control center to which the botnet is connecting. So that's what we are tasked to find out here: the IP, the port, and the C2 name. So head on to investigation 4. And here, filter for network connections. So 3 events. And as you can see, the destination IP is the same every time, which means nope, not the same. I see here. Yep. So what's the question now? What is the IP of the adversary? So we got 2 IP addresses, as you can see here. The first one is here, and it is initiated by this IP address. The second one, so here we don't have to look for these, right? Because they are initiated by the local service. But this one is initiated by system. And this is the source IP, and this is the destination IP. So I guess because it's initiated by system, and the scenario is assuming that the adversary has gained a solid foothold, which means they have elevated the privilege. So most probably the answer should be this one, because it's executed as the authority system, and the scenario is assuming that the attacker has gained solid foothold, like privileged access. So the process or the image that is creating the connection should be system, not service, as we found out here. That's why we didn't select this IP address. So the right one is this one, and this is the port, and this is the name of the C2, which marks the answers for these questions. I hope you enjoyed that. Take your time to find out more about Sysmonitor and install it on your local machine, practice it, try to create your own rules. If you are working in a SOC team, try to bring your threat intelligence knowledge and threat intelligence database to create more rules for Sysmonitor in order to expand the detection scale of the tool. So that was for today, and hopefully see you in the next video.